So now we're going to focus on the measures of central tendency and spread, but this video specifically is going to be for the measures of central tendency. So a measure of central tendency tells you where the observation tend to center at. It summarizes the location in the distribution of a variable. The score indicates the center of the distribution, whatever that center tends to be located. There are three measures of central tendency that we're going to focus on. The first one is the mean, and most of you already know how to calculate the mean. The second one is the median, and the third one is the mode. Some authors tend to think of the mid-range as a measure of central tendency. In my experience, I have not seen a computer output focused on the mid-range, but I have seen textbooks, so there's kind of like a disconnect between what is done in practice and what is being taught in the classroom. The mid-range is very easy. Like, you would just take the highest point minus the lowest point, and then you would divide it by 2, just in case you ever need this. But this three measures of central tendency are going to be the ones that we are going to focus on. So let's start with the simplest one, which is going to be the mode. The mode is the value that occurs more often in a data set. If you don't have a value that occurs often, you are not going to have the mode. And in that case, you would have something that looks like this type of distribution, where all of the observations that you have the same frequency. Remember, the name for that is the uniform distribution, or some authors call it rectangle distribution. If two values occur equally often, then that's what we call a bimodal distribution. And it's the one that looks like a little camel. If you have more than two values that occur just as often, something that looks like this, then that you're looking at what we would call a multimodal distribution. After two modes, we just go ahead and use multimodal. So examples. Let's find the mode in these examples. The duration in days of space shuttle voyages. So we're looking for the most frequently occurring values. So that would be this one, the 8s. So that would be the mode. The number of coal employees in Pennsylvania. Number of coal employees in Pennsylvania, that's it. So let's look for values that are repeated. I don't see anything. That means that there's no mode. No mode. Oops. A stopping distance of cars traveling 50 miles per hour. So here I have a situation where this is a frequently occurring value, and then I have another frequently occurring value. So when that happens, I'm looking at the camel, and I would call this a bimodal. It's supposed to be an A, bimodal distribution. So when we use the mode to describe our data set, it's usually going to be for a nominal variable here. So when we were doing graphs in Jamovi, we would always drag that nominal variable into the box, and we would ask for the frequency tables. And it would gives us something like this, where we have the variable name, we have the frequency, and then it would also give us, the percentage. So what you're doing there essentially is you're looking for the mode. You're looking for that measure of central tendency. We kind of already went through this. Remember, in statistics, what we always want is a bell-shaped distribution. That means the mean is going to be at the center of the distribution. To this side, we're going to have 50% of the distribution. To this side, we're going to have 50% of the distribution. The total area under the curve is going to be 100%. If it's a bell-shaped distribution, let me put it here, that means the measures of central tendency, mean, median, and mode, are at the center of distribution. When we have a bimodal distribution, that means we just have okay. Now let's talk about the next measure of central tendency, which is going to be the median, and the symbol is going to be MDN. I've also seen symbols that use, I've also seen books that use MD as a symbol. It sounds like medical doctor to me, but it's fine. That's what they use. They use. Remember, when we have a bell-shaped distribution, the median is going to be exactly in the middle, and it's going to separate between 50% of the distribution and 50% of the distribution. It's also the 50th percentile. The median is used to summarize a highly skewed distribution when you have interval or ratio scores. What's interesting about the median is that even if you have a skewed distribution, it will still be in the middle of the distribution. So let me draw that for you. So I have a normal distribution. The median is going to be here. I have a skewed distribution. It's also going to be exactly in the middle of the distribution. If I put the mean in this distribution, in the skewed one, it's not going to be exactly in the center. It's always going to get dragged to whatever the tail is going to be at. So that's what's interesting about the median, that it doesn't matter the type of distribution. It's always going to be exactly in the middle, splitting the distribution into 50% and 50%. When we are normally distributed, we know this. The median is exactly the same as the mode. And it's most, let me give you the next example. It's very popular when you have to make charts for income. So here we have income distribution, and the reason for that is because there's always going to be someone in your neighborhood that's earning a lot more than you are, or maybe they're earning a lot less than you are. So when we graph that distribution of income, it's going to be a skewed distribution. So here the blank space is to this side, so it would be a right skewed distribution. So if I calculate the median for this and say the median salary is whatever number, then I know that's going to be exactly in the middle of that distribution. If I calculate the mean, I know it's going to be closer to whatever that tail is, and it's going to be misleading. So median is a popular measure for explaining salary, income, that type of thing, whenever you have a skewed distribution, basically. How do you find the median? So when I already said this, when the distribution is not skewed and it's normally distributed, it's just going to be the same of whatever the mode is. When it's approximately normally distributed, we need to arrange the data set from lowest to highest. This is very important. If you forget to do this, and I forget at least once every semester, you're going to get the wrong median. You need to determine how many data points do you have. If it's an odd number, the median is going to be whatever point you have in the middle of the distribution. If it's an even number, then what you have to do is find the middle two values and take the average of that. So here I have a data set, and I have another graph here that says the same thing that I've been saying throughout this whole thing. The room number for 7 hotel rooms are those. So first ask yourselves, is this data in order? No, it's not. So the first step would be to order the data. So this is the smallest, 292, 300, then 311, 401, 595, 618, and 713. Cool. So how many data points do I have? I have 7. That's an odd number of data points. So that tells me that the median would be 401. This value here. The value exactly in the middle of that distribution. The number of tornadoes that occurred in the U.S. over an 8-year period. So we have 8 data points. That's an even number. So that means that after we order the data, we're going to look at the 2 middle values, and then we're going to divide by 2. Now look at the data. Is it already in order? I don't think it is. So let's do 656, 684, 702, I forgot my comma, 764, 856, 1132, 113, oops, 33, and 1303. Okay, so 1, 2, 3, 4, 5. These two values are the middle values. So to find the median, it's going to be this number plus this number over 2. And that is 810. That's going to be my median. Cool. So let's go to the next one. The number of meteorites found in 10 US states are. So the data does not look in order at all. So let's do that. 30, 39, 40. But the good news is once you know how to do this in Jamovi, you don't have to worry about ordering the data. The bad news is when you have to do it by hand. For me, it's usually when I'm teaching. Okay, so I have 10. That's an even number of values. So I need to find the two middle data points. 3, 4, 5. So it's going to be this two. To find the median, that would be 78 plus 89 divided by 2. And that is 83.5. Last one. So the data is still not in order, and we have an odd number of data points. So 2, 4, 2 5s, 2 7s, 8, 4 9s. Oops, that does not look good. 9, 9, 9, and 10. 11, 11, and I think that's the end. Oh no, I have a 12 over here. Okay, so because it's an odd number of data points, I can just find the middle point. 2, 3, 4, 5, 6, 7, 8, 9, and that's it. That's the one that's in the middle. There you go. Quartiles. So quartiles is not necessarily, I'm going to put a note here, not a measure of central tendency. It's actually a measure of position. That's important, just so you know. To find the quartiles, really it's all based on knowing how to find the median. You need to find the median, which is going to be the same as Q2. Then you split the distribution by that median, and then in the lower portion you find the median again. That's going to be your Q1. You look at the upper half of the distribution, you find the median for that, and that's going to be your Q3. Recall that the IQR stands for interquartile range, and that's going to give you 50% of the distribution. The formula for that is Q3 minus Q1. So the first quartile is the median, so that's Q1. I'm sorry, Q2. This would be Q1. This would be Q3. There's only 3 quartiles, but it splits the distribution into 1, 2, 3, 4, into quarters. To this side, it's going to be 50%. Each one of them is going to be 25%. 25%. 25%, 25%. When we do the interquartile range, it gives us this area. And that's also 50% of the distribution. When we're looking at the third quartile, it would give us the area from here all the way to the tail, and that actually would be 75% of the distribution. So whichever way you look at, just remember each one of them is 25%. So here we have our data set. The first thing we have to do is actually order that data set. In this case, we're pretty lucky because it's already been ordered. So what we have to do next is to find the median of the data set. And remember, the median is the same as the second quartile. And in this case, that would be 13. Next, I'm going to look at the data that's 5, 6, and 12. So this side. And then I'm going to find the median for that. The median for that is going to be Q1. It's supposed to be a Q. And that would be 6. Next, I'm going to look at this part of the data set, the upper half. And that would be, 15, 18, 20. I would look for the median for that. And that would be Q3. And that would be 18. If I want to find the IQR, I would do Q3 minus Q1. So that would be 18 minus 6. And that is conveniently 12. That is those are my quartiles and my IQR. So let's do another one. The data is already in order. Make sure it's always in order. Don't trust me. So here we have an even number of values. So I need to find the average of this two to find the median. So MP would be the same as Q2. And to find that, it would be 13 plus 15 over 2. And that is 14. Now let's do, we're going to split our distribution here. And we're going to look at 5, 6, 12, 13. So in this case, what I'm going to do now is I'm going to find the median with these two values. So Q1, which is the same as the median here for this smaller data set, would be 6 plus 12 over 2. And that is 9. Okay. Now I'm going to look at this portion of the data set. So that is 15, 18, 12, and 25. Because it's an even number of values, I look at this too. Q3 would be 18 plus 20 divided by 2. Q3 is going to be 19. There you go. If I want to do the IQR, it would be 19 minus 9. That's conveniently 10. Cool. So I have the average number of vacation days here. In this case, I don't have the data in order. So that's the first thing I have to do. This is the smallest. 13, 25, another 25. Then 26, 28. 34, 35, 37, and 42. Yes. So I find the median, which is going to be Q. Because I have 9, that's an odd number, I just look at the value in the middle, and that's actually 28. The next thing I'm going to do is I'm going to look at this portion of the data set, and that's going to be 13, 5, 25, and 26. So this is an even number, so I will 25 plus 25 over 2. That's conveniently 25. Let's look at this side of the data set. So that's going to be 34, I was going to put a plus there, 34, 35, 37, 42. So Q2, I'm sorry, Q3. That's going to be these two numbers divided by 2. Now I did need the plus there. And that's 36. Last one. So we need to order the data. So 30, 47, 48. I skipped this 39. Let's see. 39, 47, 48, 7, 8, 89, 138, 164, 215, and 296. There you go. Let me move this up now. So I have 10. So that means I need to find the two middle values and find the median for that. So these two are the middle values. Median is the same as Q2. So 78 plus 89 divided by 2. That is conveniently 83.5. Now I'm going to look at this section. And that includes the 78. So Q1 would be 47. And then, we need another color. Let's use green. I'm going to look at this portion of the data set. And because it's just 5, I can just pick the middle one. That's going to be my 4. There you go. Those are my quartiles. Now we're back to measures of central tendency. Measure of central tendency. Okay, so we're going to calculate the mean, and most of you are going to be familiar with this type of mean. I just want to go over the notation first. So whenever we use lowercase, we are usually denoting the sample. That little line on top of the X, it's what we call X bar, kind of like the bar on Friday night. I'm joking. This little odd looking E, it's the Greek letter sigma, and it represents summation. So that tells you that you need to add every value in that data, or what you need to add all of the X's that you have, basically. And it's going to represent the sample size. So we've already done this. I'm sure you've done it at some point in your life. So let's find the mean for chocolate. So all we have to do is just add those values, and we're going to divide it by the total number of values, and that's going to be our sample. Notice that I said sample mean. That tells you that that's a statistic. If I had said population mean, the symbol for that would have been a Greek letter, and it would have been the Greek letter mu. And that would have been a parameter. Okay, so it would just be 2 plus 4.9 plus 6.5, 2.1 plus 5.1 plus 3.2 plus 16.6. All of this divided by the total number of values, which is 7. When I calculate that, when I add the top is 40.4 divided by 7. And when I make this division, that's going to be 5.77. And the unit is billions, so I can just say billions. That's it. That's the sample mean for that chocolate. Okay, so that's kind of boring. We know how to do the mean for that. Now we're going to do the mean for a frequency distribution. What does that mean? What it means essentially is that we don't have the raw data. We don't have every data point like we did in the chocolate problem where we had every value. Here we have how many times that value showed up and what the value is. So in other words, the value of 94, we saw it in our distribution 6 times. The value of 103, we saw it in our distribution 22 times. So the formula for this, which not good, I did not put it here, would look like this. So we would need the sum of the frequency, which is this part, times the observation, which is going to be the x, divided by the total sample size. So how would I find the total sample size? Well, there's 2 ways. There's the easy way. It's in the problem. And then there's the calculation way where you would add the total would be the same as n, which would be 108. Notice we have to do the product in this formula, and you actually have this column for that. So what you have to do is 6 times 94, and that is conveniently 564. Then it would be 22 times 103, and that would be 2,266. And then I keep doing it for all of the rows. This is going to be 4,816, 3,388, 1,170. Okay, so what I did is I did the part where I multiplied the f. Think about it as having a parenthesis there. I multiply the f times the x. The next thing I have to do is I have to do whatever this odd looking e is telling me. That means I have to add this value, this value, this value, this value, and this value. I have to add them up to find the sum of the frequency times x. So when I add that, I actually get a very large number. It looks like this. So that's actually going to be the top of my equation. X bar to 12,202. And then I need to divide it by this number, which is 108. That's my n. The mean here would be 113. That's the answer. Okay, let's do another one for fun. So the total sample size here I can find out from here, or I could just add this column. That's my n, and n is 35. What I need to do next is to multiply the frequency times x. So 2 times 58, that is 116. Then I got 945, 1088, 146. Okay, so let me put the formula here again. Frequency times x divided by n. So I know what the n is. I know what the sum of the frequency times the x is, but I need to do this part of the equation. I need to add this column. So this number, this number, this number, and this number. The sum of frequency times x is 2,295. So x bar is 2,295 divided by 35. And my sample mean is 65.57. There you go. Okay, so when we would use the mean for the frequency distribution, so I know people like to send online surveys. Sometimes if you're not paying for that service, they will keep your data hostage, but they'll give you some information, some descriptive information like this table. And you can go ahead and find what your mean is if you need to. And there's a mean for group data. So you could also, I'm sorry, there's a standard deviation formula for group data as well. So you could also calculate that. There's several formulas for group data in case you don't have access to the raw data, which is what looking at every point in your data set would look like. When should we use the mean? Well, anytime it makes sense, basically. When we have interval or ratio data. Here I have a couple of examples. What was the average temperature? What was the mean score? When should we not use the mean? Well, when it's a nominal variable, think about the mean for gender. That doesn't make sense. The mean for ethnicity, that doesn't make sense. The mean for pet, that doesn't make sense either. Another place where you probably don't want to use the mean is when you have that skewed distribution. That's when you want to use the median. What is an outlier? An outlier is an extreme value. It can be extremely large or extremely small. So usually an outlier, what's going to do is that it's going to skew your distribution. That's why we normally don't like them. Sometimes you generally have an outlier. Sometimes it could be a data entry error. So it really depends what's going to happen to your data. I kind of already mentioned this, but let's review it again. When you have a normal distribution like this one, your measures of central tendency would be exactly in the middle of the distribution, and that makes everything easier for us. That's why we always want our distribution to be normally distributed. So remember, the measure of central tendency that you want to use for describing skewed distribution is the median, and the reason for that is because it's always going to be in the middle of that distribution, whereas the mean is going to get dragged to wherever there's an outlier. So here I have a skewed distribution that tells you that I have an outlier, and in this distribution the outlier would probably be on this side. Oops, outlier. Also remember the blank space to the right, so that makes it a right skewed distribution or positively skewed. The lines that I have here, those are going to represent, each one is going to be a measure of central tendency. So look at this one. That's the easiest one. That's the peak of our distribution. That means that's the mode. The measure of central tendency that splits the distribution exactly in the middle all the time, regardless of the shape, is the median. So this one would be the median. The measure of central tendency that gets dragged towards the outlier, it's the mean. The mean, it's, in other words, very sensitive to outliers. Okay, let's do that again. So I have a blank space. That means this is left skew. That means that my outlier is on this side. And then I have the lines which represent each one the measures of central tendency. So the peak of my distribution, I know that measure of central tendency is the mode. I know that the measure of central tendency that's closer to the outlier is always going to be the mean. And that leaves me with the median, which I know it's always in the middle of the distribution. So finally, we're going to go over what we call deviations from the mean. Deviations from the mean by itself is not that interesting, to be honest, but I like covering it because it's going to be the basis of what we do when we learn about the measures of variability or the measures of spread, whichever you want to call them. So the formula for that is very simple. Is x minus x bar. So x is the observation minus the sample mean. Remember this x with the little line on top? That's always going to represent the sample mean. Usually deviation is the keyword for error. So every deviation we calculate is going to tell us where the observation is. And if it's a positive deviation, it's going to tell us, oh, it's above that data point or it's below that data point. In other words, it gives us the distance and direction from the mean. The distance is going to be the value of the number. If it's a large number, that tells us is very far away from that mean. The sign is going to tell us the direction from it. If it's a negative, it's going to be below the mean. If it's positive, it's going to be above the mean. We also have to sum the deviation, the sum of deviations for the mean. And this needs to add up to 0. If it doesn't add up to 0, it means we made a mistake somewhere in there. Basically, when we find all of the deviations from the mean, they're going to cancel each other out. So when we add that, it should be 0. So here are a couple of steps to calculate the deviations. First, you need to find the mean of the data. So let's do that over here, not in the table. So it would be 22 plus 29, 30, 36, 37 plus 41. All of this divided by however many data points I have. Let me actually count them. 1, 2, 3, 4, 5, 6, 7. So it would be all of this divided by 7. And this actually comes out to 32. So that means x bar is 32. Look at my table. This is my x, and it's going to be x bar. So the mean for this data is 32. In this column, essentially what I have to do is 32 over all of the rows. The next thing I'm going to do is I'm going to find the deviation. So I'm going to do 22 minus 32, that is conveniently 10, but it's actually negative 10. So the next one would be 29 minus 32, and that is conveniently negative 3. And I can do the same for all of them. So again, negative 3, negative 2, positive 4, positive 5, and positive 9. So here I already found the deviations. For example, 22 is the direction of that observation with respect to the mean is below the mean, and the location is actually 10 points below whatever that mean is. What I want to do next is I just want to add the deviations, and the reason I'm doing that is I want to check that they add to 0, and that tells me that I calculated my deviations correctly. So cool, yeah, they do add up to 0, so the deviations are correct. Again, the deviation by itself is not that interesting, but once we get to the measures of variability, it's basically going to be the basis of calculating what we were going to call the standard deviation.